Okay, for this question, we've got this random variable x, such that x is a binomial distribution. The number of trials is n, and the probability of success is 0.25. And we need to find the least n, such that the probability of x is greater than or equal to 1 is greater than 0.99. So the probability that x is greater than or equal to 1, well, that is going to equal 1 minus the probability of x is equal to 0. So just remember, all the probabilities must sum to 1 in the probability distribution. So if we had, say, the probability x equals 0 plus probability x equals 1 plus the probability x equals 2 plus, and we don't know how many we've got, but all the way up to the probability x equals to n, that must equal 1. Okay, so if we want the probability that x is greater than or equal to 1, that is all these ones here. So just rearranging that, we get 1 minus the probability of x is equal to 0 is the same as the probability of x is greater than or equal to 1. So now we just need an expression for the probability of x is equal to 0. So that means we get no successes. So if the probability of success is equal to 0.25, then the probability of failure is going to be 0.75. And if they're all failures, that's to the power of n. Okay, so now we can rewrite this as 0.01 must be greater than 0.75 to the power of n. So now I'll just take logs of both sides. You can take log of any base. It's going to work as long as it's the same base on both sides, obviously. I'll just take the natural log. So I've got 0.01. The log of natural log of 0.01 is greater than the natural log of 0.75 to the power of n. And just using the rules of logs, I can bring that n down the front. So n times the natural log of 0.75. And now, just got to be careful here. If we've got a log and the number inside the log here is less than 1, but bigger than 0, it's going to be negative. So when we divide by a negative, we need to swap the inequality sign over. So now we're going to get the natural log of 0.01 divided by the natural log of 0.75 is going to be less than n. Okay, so now we can work that out on our calculator. So we'll bring our calculator up. Okay, so we've got it in there, natural log of 0.01 divided by natural log of 0.75, and that is equal to 16.0078. So we'll write that in. So that is 16.0078, and n must be greater than that number. So remember, n has to be an integer when we're dealing with the binomial theorem, because that is the number of successes or number of failures, etc. Okay, or the in this case, it's just the number of trials. So we want to know how many trials we need to do to get that probability. Okay, so 16 wouldn't be enough because we need slightly more than 16. So if we had n has to be greater than or n equals 16 wouldn't be enough. So n must be greater than 17. Okay, and that is the final answer.